Hello everyone, my name is Alejandra Belmont and I am a chemistry peer leader here at the University of Texas at El Paso. Today we will be going over Hess's law, which is part of the chapters that we have to do for chemistry. Alright, so this problem is particularly similar to a problem in Module 8. It's problem 4 on your general chemistry workshop workbook. So we're going to go ahead and get started. So what you're given is this equation, and this is going to be your goal equation. There is a thing called the direct method. There's another thing called the indirect method. This problem is an indirect problem. When you do have an indirect method problem, you're going to be given a set of equations that you have to manipulate and rearrange to make them look like that goal equation that you're given at the top. Alright, so we're going to go ahead and get started. Basically what I like to do is I like to go through every single one of the compounds that I'm given up here. I have carbon disulfide, oxygen gas, carbon dioxide, and sulfur dioxide. So I'm going to go ahead and get started with my first one. My first one is CS2 in liquid form. You have to pay attention to these because the states of matter, they have to be exactly the same. So I'm going to look for this one within my other three equations, and I see it in my third equation, right? But in my third equation, it's on the product side, not the reactant side. We want it to be on the same side. So what I'm going to go ahead and do to the third equation is flip it. And once I do flip it, I'm going to have CS2 liquid yields C solid plus 2S solid. So what happens when you flip an equation is your enthalpy of the reaction is going to switch signs. So this one is positive. Once I did flip it, it's now going to be negative. So I'm going to have delta H negative 87.9 kilojoules per mole. Alright, so now that I have CS2 liquid form where I want it, I can move on to the next one. This oxygen gas is a little bit more complicated, so I'm going to go ahead and skip it for now, and I'll come back to it right now. I'm going to move on to the products, which I have carbon dioxide. Carbon dioxide is my first one, so I'm going to look for it in my reactions. It's in my first one. I have CO2 in gas form. I only have one of them, and I only have one of them, so it completely matches. They're both on the product side. So I'm going to move on to the next one. I have sulfur dioxide, and I have two of them in gas form, so I'm going to go ahead and look for SO2. My second equation gives me that, but it only gives me one of them, right? So I need two of them, so I'm going to have to multiply the whole entire reaction by 2. So times 2. And then you're going to have 2S solid plus 2O2 gas yields 2SO2 gas. Since I multiplied the whole reaction by it, I also have to multiply the heat of reaction by 2. So I'm going to have negative 296.8 kilojoules per mole times that 2 that I multiplied the rest of the reaction by. Alright, so if you guys notice, now I can go back to my oxygen and everything is a lot easier. So I'm going to have 2 oxygen gases on the reactant side on my second equation, and my first equation gives me one of them. So I can actually combine those two. So I can have this one, O2 gas, plus this one for my second reaction, plus 2 O2 gas should give me 3 O2 gas total. So now that I have this matches my goal equation. So I'm basically done comparing everything and matching it up to the goal equation. Alright, so once you have those, you can cancel out everything else that isn't part of the goal equation. So for example, this carbon that's in solid form, it's not in the top equation, so you can look for something to cancel it out. When you do cancel stuff out, you need to have one of them in the reactant side and the other one in the product side. So for this carbon, I'm going to look for the one that I can cancel out with. It's in the third equation. This one's in the reactants, this one's in the product, so I can cancel it out. I need that oxygen, I need that carbon dioxide. The sulfur in solid form, I can cancel out as well. I have 2 of them, right? So I'm going to look for something that looks similar or exactly the same. I have 2S over here in my third equation, so I can cancel those out 2 as well. And then I have 2SO2, which I need, and this one I also need, right? So once you're done, everything that you're left with should be that goal equation. So I have these two combined, this O2 and this 2O2 combined give me my 3O2. That 2SO2 is one of my products. This carbon dioxide is also one of my products. And then I have CS2, which is one of my reactants. So once you do match up everything to your goal equation, all you have to do is look at the heat of reactions and add them all up, right? So I didn't do anything to the first one, so the values stayed the same. The second one I multiplied by 2, which gives you negative 593.6 kilojoules. And the third one, I ended up flipping, so it went from being positive 87.9 to negative 87.9. All right, so once you do that, you just add all of these up, and you get a total enthalpy information of negative 1,075 kilojoules per mole. Thank you.